similar to the labs. And then if we get done with that example, then we're going to start on the lab. And tomorrow, I might finish the lab. Similar to the lab. And then if we get done with that example, then we're going to, okay. So now that it has repeated myself and it recorded me, I know it works. Hey, right, the labs are working. Okay, so what I did is I downloaded the thing from Coursera that said examples of functions. And we're going to do this together. You can ignore the whole naming it something in lab because you can name it whatever you want to, save it to the desktop in here, just whatever. So what it's going to do, because this used to be one of the labs that I had turning in before I had guidebooks. So anyway, we're going to start at part 0. We're going to define a main function, let you see what having a main function in a program looks like, because we haven't done that in Zybooks yet, because Zybooks uses scripting to test it, which I don't like. I don't like scripting. I'm old. So we're going to do a main function. We're going to do some regular functions to compute. There's a P in that word. Some areas and things like that, just to show you how to set them up and use them. All the formulas are in here, so you don't have to actually remember the formulas. We're going to import math where we can use some of the math. So we're going to start pulling it together and actually use all those different components that I've been teaching you. And I'm hoping this is where those of you that are kind of confused will go, now it makes sense. The light bulb moment. This is my hope, that this section makes the light bulb go off after I talk, not after you read Zybook. After I talk. All right. Then we're going to do some printing of characters. And then at the very end, we're going to draw some boxes with our turtles, because you need to be able to draw to do when it's turned in. Yes, this is being recorded. That being said, I checked my YouTube channel today before I came down here. On average, most of my recordings are getting 6 to 12 hits. There's 42 of you that have access to that channel. So I think I'm wasting my time. All right, but I'm gonna keep doing it because I'm a nice person. Yeah, I have 20 online students, 6 hits on average.
Now that we're doing way more of those stuff, it's
maybe not. Hopefully, fingers crossed. All right, so let's get started. Everybody, open up idle. We're gonna do this together. Do you want to type or you want to help?
I can take.
Or either, whichever one works better for you.
Stand back there and make sure everybody gets going good, and then we'll go from there.
Oh,
all right, so Garrett's going to stand in the back. So if you are having problems while I'm talking and typing, wave your hand and he's going to come check on you. I may or may not slow down and stop and wait on you. Just depends on whether or not you're really stuck. So anyway, can you read the directions from back there?
No.
No, that's what I need to hear. Better?
I'm gonna ask.
This one you need to go to Coursera, download it. You can have it in the background. Idle, I'll try to make big enough for you to see. There are plenty of seats up here close to the board if you want to get closer to be able to see. Why didn't that open? There it goes. It did open. Okay. All right. So we have idle. It opened with a shell by default. So the first thing I'm going to do is go to new file and create a new file. I'm going to close the shell window just so I don't accidentally start typing in it. Because if you turn in the file you saved from the shell, I'm not grading it. I'm going to say no, bad you. So, first things first, I always save it just because in here, if you're in the lab with me and not on your own laptop, save it to the desktop for right now. I'm going to call it examples. You can call it whatever you want to. So I've got this going. I'm going to make it bigger where you guys can see it in the back, I hope. I need 2 screens. So, oh my God, it's going to kill me. All right, so part 0 wants us to create the main function. First thing we're going to do. Well, you can copy and paste this, or you can just type it in, def main. And the main function always starts off exactly this way. Always. And we're going to have a print line inside of our main that's just going to tell us what this was. This is supposed to be lab 4 or was lab 4 before, but we'll call it examples. You can call it whatever you want to. By me. And why am I putting that print line in there? Just for my main's not completely empty, setting up a framework. Also make sure your name's in the file, so when I run it, very clearly has your name there. And yes, your name does show up at the top of the thing, you know, that I downloaded from Coursesden. But if it's right there, I don't have to look for it. And I don't have to worry about whether or not you named your files appropriately. All right, so then I'm going to hit enter several times and put some white space in and put the word main, open quotes. So this last line is calling the definition of main. It should be the last line of your Pi files from here on out. If you don't make it last, the stuff under it doesn't run. Does that make sense? If you put more than one main in your code, Python will only run the last one you define. And it will ignore the others. It will not give you an error message, which drives me insane. You should not have more than one main function defined in your code. So I have a main and I'm ready to get started on this stuff. So if I run this now, it prints the print line, right? That's all we told it to do. All right, so the next step is to compute the area of a circle. We want to create a function that does that. I even told you what to name the function and gave you the whole definition line. So because I am lazy, I have to put everything above that last line, right? So I'm going to put it in the white space in between. And I'm going to define a new function. So DEF means definition. The blue words are the name of the function. The things inside of the parentheses are parameters, which are variables that hold the information the function needs to run. So in this case, to compute the area of the circle, we have to know what the diameter of the circle is to do that math. So diameters are parameters. Diameter is how wide the circle is. It is 2 radiuses, yes, but anyway, radius is half the diameter. Anyway. All right, so inside of there, I need to use math.py. Oh no, I'm using another module. What do I need to do? I gotta import it before I can use it. And because I'm an old school programmer, I'm gonna go back up here and I'm gonna put my import statement before my main. Because I had a professor years ago that taught me to put my import statements first.
There's an error if you put import someone else.
Nope. As long as you import it before you try to use it, you can put it anywhere you want to in the code. Kind of a pain in the butt if you're.
It's best practice, but at the top still.
Yeah, most of the professors are going to want you to have it at the top. The reason I discourage you from putting it somewhere in the middle of the code is it's easy to forget it. And then you're like, why doesn't it work?
I do think if you have an import statement underneath where you try to use it, it won't recognize it.
Right. If you try to use it on line 10 and you don't put it into line 15, it's going to give you an error message. And you're going, oh, I imported it, but you didn't import it soon enough. So you might as well put it first.
Programming reads from top.
Always reads from top to bottom. Unless it's calling functions that are written below it, and then it jumps down there, and then it jumps back.
Always, unless.
And it's like the English language.
Rule.
It's like the English language. There's probably more exceptions than there are rules. All right. So if I'm computing the area of a circle, anybody know what the formula for area of a circle is? Pi r squared. No, pi r squared. So we're passing in the diameter, but I need the radius. So the radius is equal to diameter divided by 2. Numlog wasn't on. Right? And you're going, why didn't I just pass in the radius? Because then I couldn't show you how to do this. And because we want it to give us decimals, if we divide it by 2.0, it creates radius as a float. And we don't have to convert it later. Now we want the area, and that is going to be equal to math.py, because sure. I just said that. I divided it by 2.0 where it keeps it as a floating point number and you have decimals in your answers. If I had just put 2, it would have made radius an integer variable and it would have thrown away your decimal points. Potentially.
Conversions later on.
And then you would have to do conversions, and this just makes it easier. In Java, you would have just defined it as a float and gone on. So math.py is already defined for us. We don't have to remember that pi is 2.14, whatever. We're going to multiply that by the radius squared. And remember the 2 stars indicates raising it to a power, right? This all coming back to you from weeks ago. Somewhat? Possibly.
At least as much.
And then I can return, once I learn to spell, area. So remember, functions can create data and give it back to the program. So I've created this function. And if I did my typing right, the math should all work because it was all given to you. As long as I don't have any typos in it. So if I run this now, what happens? Nothing. Because we haven't actually called the function. We created it, but like main is called down here, we haven't called it. So we want to call all of our new functions inside of main because main is going to be our driver. It's like the bus driver of our program. It's going to make everything go. So all of our stuff is going to be tested and called in the main function from here on out. So I'm gonna go up here under my print line. And I'm gonna tell it that I want to print compute area circle. And for right now, I'm just going to test it with some value. I'm going to put 3 in there. And it should, at this point, this line tells the computer that I want to go to the function compute area circle. I want to give it a value of 3. Then 3 will be used inside the definition everywhere the word diameter is. That makes sense? Questions? Once that is, all these steps are done inside the definition of compute area of the circle, it returns whatever that value is to the print command. So then it prints whatever number the function created. So if I run that, the area of a circle with a diameter of 3 is 7.06858347, blah, 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 blah. Right? So does that make sense? Questions? Now, I printed it there, but I also could have just stored it as a variable. Could have put area. And then I could come down here. Does exactly the same thing. But in this case, by creating a variable and setting it equal to the function call, I now saved that data into the variable and I can reuse it over and over again until the program's done. That makes sense? So there's 2 ways to do, at least 2 ways that you can do definitions or function definitions that have return types. You can either store them into a variable to be used at your leisure, or you can do them into a print statement that automatically uses it, pushes it out there. Or if you're doing a formula, you can put it into a formula, do some math with it, automatically use it. But you don't store it into a variable. It's gone after its initial use. All right, people make eye contact with me, do some nodding, let me know we're not completely lost. If we're completely lost, go.
When we're only partially.
Okay, thumbs up if you got me. And I kind of got you.
I got you for now.
Please start over. Put your thumbs in. Okay. All right, so I don't have to start completely over. Clarifying question. Do you have something that I could make it easier?
I have a question. I didn't really get it when you explained why we have to print the area variable.
If you don't print it, you don't see it. The printing is just to show it on the screen that it ran. So if I left, in this case, if I didn't put this line in here and I ran it, you on the screen, you only see the print statement. It still did the calculations and stored them. We just didn't display them. Does that make sense? And you know, I could still use area for other stuff. Yeah. The 3 is just some random number I just pulled out. The circle I'm working with is 3. It's got a diameter of 3. It could be 23, and it's just going to give you a different Hopefully, it's going to give you a correct answer, but it's just going to give you a different answer based on the size of the circle. So that's computing the area of a circle. So if you want to test it and see if it was right, you could have used 8 because I gave you the answer for 8. And match it, right? Yeah. Now, to make this more useful, oh, we're gonna skip circumference right now. I don't want to remember the math. Shh, hush. To make this more useful, up here we could have a statement that says diameter equals input float input. Enter the diameter. That's not easy to spell when you're typing. And then instead of putting a number here, we could just use diameter. And then this way, when you run it, there are messages. This way, when you run it, I can enter the number. Now it's more useful. Anybody can use it. They can calculate the diameter of any circle they want to. Does that make sense? Yeah, I know you're waiting on me. So, moving to character lines, what if I want to display a line of characters in a function? So you can do math equations with it, but you can also do print things, you can do all sorts of things with it. So if we're just going to play with displaying stuff, this function probably will not have a return value because it's just going to print directly to the string. So a lot of times you guys have asked me questions about, I don't understand what it's asking me because it used weird wording. Anytime you see something like display, you're printing to the screen. Computing, you got a formula you've got to figure out. Does that make sense? So in here, I want to be able to print whatever character my function's given, the number of times that the user tells me to. So if I'm printing something a number of times, I need a loop, right? Because you're repeating. Is this helping you with terminology? Figuring out what they're needing? So I want to have a for loop because it's we're counting. I want a for loop for I in range count. So whatever value the user passes in will be stored in this variable. That variable will be used in our for loop to tell us how long we're going. And then inside the for loop, we're going to print whatever output is. And we're going to use the special character end equals I think it says a single character. Now, not a lot. We're doing a special character. And we had to do this in some of the labs for the last chapter, right? This means I don't want to go to the new line. End equals means I want to end the line with whatever is inside of the quotation marks. If there's nothing inside the quotation marks, then it ends with nothing. No space, no return character, no end of line, right? So that'll make them print right next to each other. And then, of course, I need to finish out by closing my parentheses. Does that make kind of sense? So now, this one's not returning anything. It's just printing stuff. And to save us some time, I'm going to comment stuff out where I don't have to go through all of the tests for all of them when I'm testing this one section. Now, if I do this display character, and I give it an exclamation point and 5, it should this mouse has got some issues. It should give us 5 exclamation points right next to each other. Yes? I know you've got it.
At least you're getting something back. Come on.
This is what happens when you have to take class out of order, right?
Yes.
So, does that make sense? No?
I can read it.
So, to summarize what we have so far, to pull it out, try to pull the big picture together. I've imported math, so I know I'm going to use some math functions. I've created a main method where all of my other methods are going to be tested and called, and it's going to drive forward the rest of this program. I've defined a function that does math and returns a value. This is compute circumference or area, sorry. And I've also defined a function that just displays or prints information to the screen and has no return value. And I showed you how to call them in the main. Yeah, I do realize you have a test coming up next week, so questions? Okay. If you come up with some, let me know. So let's talk about turtles, because turtles are very important for what you have to turn in for me this week. Because they're going to do your drawing of a school bus. If you haven't already read it yet, you're going to draw a school bus. So let's talk about turtles. And I think I've introduced turtles in some of the slides before. I don't know how much of it we actually coded, but we're going to code it now. So I already know I need another import statement. And yes, there are ways to put multiple imports on the same line, but if you're not doing but 2 or 3 of them, sometimes it's just clearer to just give them each their own import statement. That way you don't forget one, or you don't have a typo or something. So I'm going to import turtle. I'm going to come down here, and I'm going to create a function called draw square. Right? And draw square is going to need a turtle to do the drawing. And it's going to need a size. Because we want to be able to change how big the square is going to be. Because it makes it more useful than me saying, oh, well, all the squares are going to be 300 pixels. Because, you know, how often are you going to use a 300 pixel wide square? I don't know. But if you can change it, you can use it whenever you need a square. So, 2 parameters, turtle and size. Where am I getting the turtle from? Well, we're going to create that turtle in main before we call the function. Because we're going to use the turtle module that we just imported to create the turtle to do the draw. Yeah,
The way turtle works, is there any reason we're not using, creating the turtle in the draw square?
because we're passing it as a parameter. If you create it and draw a square, every time you draw a square, you create a new turtle. And then you have lots of turtles. And we don't want lots of turtles. We want just the turtles we need. And the variable name, if it was inside the function for the turtle, would be a local variable. So you wouldn't be able to access that turtle again, except inside that function. An whole scope and sequence thing. Scope and sequence. Great thing. So turtle is going to go forward size. Then turtle is going to go right 90. Right? Oh, wait, I need a loop for that, don't I? For I in range 4, because our squares have 4 sides. Right? Make sense? Now, I don't have to print. I don't have to display, because by definition, the turtle does these things inside of its screen and it's automatically gonna draw. Because that stuff was all handled in the turtle module. So up here in main, I'm gonna create a turtle. So Alex is gonna be I hope my memory's working. It is good. But before I do that, I have to do a screen. So let's call it. I always call it world. I know that the directions say window, but why? Because the turtle lives in a world. You want to call it a window, you can call it a window. My turtle has a world, right? If you don't know the functions for that, they are down here further down in the directions. So I have a world for the turtle to live in. I created my turtle, and now I can call draw square. And tell it Alex is going to be my turtle, and I want the box to be 100 pixels wide. And when I run it this time, because I have everything else commented out, I should just have the window pop up and draw a box. Right? Yeah. Does that make sense? This
Thumbs up.
thumbs up means good. Thumbs down means no. I got 2 people telling me thumbs up.
Can you go back to the screen?
Oh, yeah, I can go back to the.
To see how you get track of this.
Huh?
Oh, I'm going to scroll up where you can see the function. So all this does is the moving the turtle around in a square. All the function does is move the turtle around the screen. The commands in main actually create the turtle and the screen, and then call.
Under main, where they display character lines.
Yeah, all this is main.
Only there was curly braces to tell you where the area.
Remember, tabs define where you're at. And so everything tabbed in under main belongs to main. Question, throw them at me. Just don't throw objects at me. Well, you can throw computer objects at me, just not real objects.
That was bad. That was bad.
Programming objects you can throw at me, not physical objects.
Huh? No, we're not DDoSing.
Hello, please don't DDoS the school.
This is literally the networking teacher. I think you're the one who probably understands DDoSing.
Do not do that. Bad. Yeah.
I'll have to make her go and do all the work she did. Usually when she did it all in this building.
Not my job anymore. I don't have to fix it.
Your son's job now.
I just don't want to have to like wait on it to be fixed. All right. So here's a little challenge for you. Remember the example I did like last week or something where I told you that we were going to move our turtle, we'll have our turtle go to negative 300, 300 and draw a box, and then we drew a box next to it. Right? You remember that? How would we accomplish that with the functions we have right now? Right? So if I wanted to do what we did before, I would tell Alex to pick his pen up. Yeah.
I'm just gonna need. This seats now.
Yep. Good call, Garrett. And then I want to draw a square. Oh, wait. Don't forget to put the pen down. Change this to 300. And then copy paste is your friend
Enemy.
and your worst enemy sometimes. So if you take all these lines of code right here, it creates a world, creates a turtle, picks the pen up so the turtle's not drawing, moves the turtle to the top left-hand corner of the screen if you're looking at it. Right, yeah. If you're looking at it, it's top left-hand corner. Puts the pen back down where we can start drawing. It draws a square that's 300 pixels. Picks the pen up, moves over, puts the pen down, draws another square. Right? So after I run this, I should have 2 large squares at the top of my window. Does that make sense? You want me to prove it to you by running it? Yeah. You don't have to take my word for it. I will always prove it to you. And I am going to promise you that there are days that I will mess up, and when I try to prove it to you, it will be wrong, but then we'll fix it. All right. Does that got y'all kind of like at a point where you think you could start doing some of this on your own? Got a couple of nods. I got a couple of blank stares.
I'm not sure.
I'm happy with not sure.
I'm certain.
I have some faces that are hidden by screens that I haven't seen all semester. Remember, I'm short, so if you are too, I don't see your face. Questions?
Comments, concerns.
On things like Alex, the very first one, Alex. Alex got up.
Alex got up, okay. Up comes from the turtle module.
That's just
Anything?
where he started. He said.
That
Why
just,
is it blank?
Alex up, all it does is say, I'm picking the pen up. My turtle's not gonna draw. That's all up does, and down puts the pen down. Go to moves the turtle magically to some point on the screen. Whatever's inside of it. Yeah, whatever the X and Y coordinate is, you give it. It knows to use the turtle functions from the module because of the dot notation. The name dot function means go to that object's functions. So if you notice up a few lines that's in red here where I commented it out, I don't have any dot notation. I just have a function call. That's because that function is in the file we created. It doesn't have to go looking for it. If you have a dot in it, it says, oh, I'm going somewhere else to look for it. And I'm going wherever, whatever file created Alex to find my methods.
How would you mess that up? By not putting Alex up?
By not putting Alex in front of it. But if you just put up, it wouldn't work.
You just put Alex dot up. You start out with Alex dot go to 300.
It would do it. It still would go to. It would just have a line drawn across the screen. Let me show you.
I'm trying to get, you know.
Yeah. What it does, if you got some random line that you didn't mean to be there, that means you probably didn't pick your pin up before you repositioned your turtle. If you reposition your turtle without picking the pin up, it draws that line when it repositions.
Even when you're starting.
Yeah.
It might not be there.
Yeah, because it, by default, the turtle starts in the center of the screen with its pin down. So if you start moving without picking the pin up, it starts drawing. I also am going to tell you this about turtles before you get into the lab, because you're going to run into this. It's in layers. So whatever you draw first is kind of like the background, and if you draw something on top of it, it will cover it up. So let me open that file. If I can find the right window. Way too many windows going here. And show you what I'm talking about. So if we go grab the lab file. And I open it up. And we'll make it a little bit bigger where you guys can see it. Keep away. We'll forget about the stuff at the top. I have you, as the last portion of it, drawing me a school bus, right? Come on. If you do this in the wrong order, say you do the initial portion of it first, or you draw your initials, and then you put the yellow box on top of it, you'll never see the initials because the yellow box will cover them over. That makes sense? So do it in layers. The wheels are 2 circles. If you do the inner circle first, the outer circle will cover it over.
Slides do Tuesday, right?
Let's do,
Yes.
yeah, let's do on Tuesday. I may push it back to Friday. Because I'm trying to get you used to doing it my way and not the right book way.
Curious, do we need to import something else for those wheels or?
No, if you go to the API for turtles, there is a way to draw circles. You just have to look it up. There also is a function for filling in shapes. But I want you to have to look some of it up. So what I am going to tell you is the first 2 parts of it are just practice doing what we did today. Creating functions that compute something in print, you know? So they should be pretty quick. Whoa, thought that was a minute. Remember, right here is the formula under B that you need. So remember, if you have questions about the math, email me and I'll give it to you, but it's there and there too. So part 1, I know it says assignment 4, but it's lab 7. This is an example, not a literal, an example of how you should set your file names up. This one wants you to compute the area and perimeter of a regular hexagon. What's the perimeter of a hexagon? It's all the sides added together. What's a hexagon? How many sides does a hexagon have? 6.
Sorry. 2 minutes since I did that.
So length times 6 gives you the perimeter, right? To get the area, I give you the function that you need, or the formula you need. You're going to use the square root function from math. It's a lovely thing, does all of it for you.
Square root theory, that's a side, but also square root side. Again,
3 is just an example. You want to replace 3 with side.
oh, that's it.
So the this formula, leave the 3. It's part of the formula for computing the area of the side goes where side is.
But I see like the square root and regular square root, kind of 2 at the top right of this side.
What?
Okay, well, the side square.
Side squared. So put 2 stars in there and a 2.
Okay.
Oh, y'all make my life hard. The bus, you're going to create 1, 2, 3, 4, 5, 6, 7 functions for the bus. Yeah.
What are they?
The bus will import turtle. The math will import math.
So math, turtle.
Math and turtle are the only 2 things you should import for this. If you want more functions, because you like making functions, you can have more functions, but you need these functions. Now, guess what? The windows are squares. Yeah. Yes. If you think back to the slides I showed you, I told you you can change the colors the turtle's drawing in. There's a function for that. There's a function for fill color.
Your biggest friend with the API for turtles.
And in the slide deck, there was a link to it.
API for turtles.
But you also can go Python, turtle, and documentation. There you go.
Every single function.
And then everything the turtle can do is in this documentation. Oh, look, forward, backward, right, left, go to, set X, set Y, set heading, home, circle.
That's the question, the backward, BK, and back, is that all?
Those are alternate things you can use to call it.
They all have the same result.
They should.
I have a question.
Uh-huh.
So if we're drawing the circle, like, how do we put in the axis then? Exactly.
Well, what you do is you hit circle and you tell it the radius, the extent, and the steps. Guess what? You don't have to have the other 2. You just have to tell it the radius of the circle.
That one's gonna be a run it, test it, run it, test it.
Run it, test it,
Until
yeah.
you
So
think
it
it
does
looks
it
good.
for us?
Yes,
Yeah.
it does it for you. You put the Rogers. It's amazing.
This page right here is gonna be your guys' best friends, because it's gonna include the method for getting colors, it's gonna include the method for filling color, all that stuff.
So this gets you this. All you have to do to draw a circle is put a number for how big the radius is.
The question now, turtle starts drawing this, is starting position the edge of the circle or the radius of the circle?
That's a good question. When you position your turtle, you need to draw an imaginary box around your circle and give it the starting left-hand corner.
So the turtle's in the upper left corner.
Mhm.
So everything, the entire circle will be like down and to the right of it.
Mhm. You've done some Java graphics, haven't you? Yeah. Yeah. So your circles, your tires are going to be trial and error. Once you figure out one of them, move straight over to do the other one. And I promise you, your school buses are going to look janky compared to the one that I just showed you. Because somebody, not me, somebody spent a lot of time figuring it all out that had a lot more experience programming than you guys did. So don't get weird or, yeah, don't cry, or they're also the head of the department. If your circles are not perfectly on an exact spot you wanted them on the bus, don't get all bent out of shape if your windows are not perfectly proportional to the bus. Put
It
some
looks like a
windows
bus.
on it, put a door on it. If you note on the picture of the bus,
Colors can be a little different too. You don't
your
have to
colors,
be
your
exact.
colors may not be the same shape. They put a doorknob in the middle of the bus. Come on.
So we don't need to do that.
You don't need a doorknob.
Do we need to do the?
I've had people do snub nose buses, so they didn't want to put the engine compartment on there, but as long as it looks like a school bus, when you're finished with your initials on it, I'm good.
Yeah, put the tire,
Axle hub thing, yeah.
yeah. The rim.
It should just be half the radius.
It's probably not, but you can just have the radius and same starting point, just change color.
But remember, you're gonna want to know the
It's like
tire
the turtle
first.
starts at the.
Otherwise, you're gonna lose the hub.
Right, but
The-
Never mind.
The positioning is my
Because
concern.
remember, layers on top so that tire's.
if it's that big a deal, no. But if I have confidence you can do it.
Yeah.
Only problem I have with this is positioning's gonna be.
So tomorrow in lab that most of y'all don't come to or don't log into, I will be helping people do this. If you don't come, good luck. Hope CSX is in your future. Send me some emails. Yeah,
I'm guessing it's like.
this is gonna be a lot of lines of code
Yeah.
because you're gonna do a lot of pin ups and pin downs and go tos and stuff like that. Is it gonna be tedious?
Yep.
Yes. Welcome to computer science. You are now officially coders. Welcome to the tedium that entails. And if you don't believe me, ask Garrett or, oh, I know your name. Wait a minute.
T.
They should have been coding this whole time.
We have another class, we have another.
Yeah,
class
I know.
with me, So you.
I know your name, I know it. I don't want to give it to her though.
All right, give it to me. Come on.
Hey, Joe.
Tristan. All right, Tristan has taken some other advanced courses. Garrett definitely taken some other advanced courses. Programming is not necessarily hard, but it is absolutely tedious.
It's a lot of trial and error. This
A
is
lot
gonna
of
be-
trial and error, especially with graphics. Yes,
this is
sir.
This presents.
I record some of them, but not all of them. I probably will record this Friday. If there's enough people here to make it useful, if it's just 2 or 3 people here and I'm just answering individual questions, that it doesn't make sense for me to record it because it doesn't make sense
Change the numbers.
to you watching it. So I suggest that since you all signed up for a course in person that had a Tuesday, Thursday, Friday schedule,
Roughly 100 lines.
that you start coming to some of the Friday things, unless you perfectly understand it and everything's starting in. If you've got an A, fine, don't come. But if you're sending me emails or you're not turning things in or you're not completing assignments, you need to attend Friday. since you're generally here, remind me to record and remind me to open the online portal for the online students. That make, you're all good. So one thing I do want to show you in the API before you get out of here. Down here under pen controls, there's pen color, color, and fill color. Fill color is what you need to color in those boxes. So before you draw something you want to be a solid color, like the square bus, you want to change, you want to say fill color, begin fill, then draw the square, end fill. That makes sense?
So what's pen color?
It changes the color. Pen color changes what the lines are. Fill color changes what it fills in the shape. Pen color changes the line. Color, you can just use regular color and everything from there down is that color. You have a lot of options. And like I said, if you come Friday, I'll do some of this in class with you. Otherwise, you have to look it up yourself. And no, I'm not doing it all because I'm trying to teach you to look stuff up yourself because you're gonna need it later. You're gonna need those skills.
Like, one thing about Java is it recommends that
Seems a
when you
little-
type in the methods.
That is the IDE, not necessarily Java the language.
Yeah.
Some of those lines are like short characters though.
Eclipse will give you some,
Yeah, that's true helpful.
you can use, PyCharm and stuff might do that. Idle doesn't. Does it suggest functions for you in PyCharm? Depends. So, all right, questions for me before I turn you loose because it's 4:30. We could go another 15 minutes, but you'll probably all want to get out of here before the traffic gets bad. I do.
Yeah.
Questions before we go? Have I completely confused you all?
Not quite.
So confused,
But is this helping pull, specifically, is this helping pull together the concepts that we've already learned?
slowly.
And that is the goal of this week. Now, like Tristan asked, is this due on Tuesday? Right now it says it's due on Tuesday, but I am willing to push it back to Friday of next week if we're making progress. But I don't want to push it too far back because
You're gonna not do it till the day before.
there's a bunch of you that wait till the day before to do it. And I'm not moving the due date until I see how many have been turned in on Tuesday. So if 90% of the class has turned it in Tuesday, I'm just gonna say it's done. So don't count on an extension. Does that make sense?
Yeah.
Also, if you've done part of it and the due date comes up, turn in what you got. I give partial credit. I have so many people not turning in anything that I have to give zeros to. It breaks my little heart. Partial credit is a good thing. Doing nothing and not reaching out to me is a bad thing. Tomorrow's withdrawal day. Anybody that is concerned about getting caught up or getting a good grade in this class because you have not got a good grade. Tomorrow's the day you make that decision. If you need to talk to me, you need to get on my calendar or you need to get an email to me tonight where we can try to do some back and forth tomorrow before, what is it, midnight it turns off, I think. Not positive on that.
I think it might be about 11.
But that being said, most of the people I think are in danger should have gotten an email from me already. But if you have concerns, come talk to me. I am in my office tomorrow from 1:30 to 3:30. And I am always reachable by email. Do not email me in course in. If you email me in course in, I'm not going to see it for 24 hours, probably. And if you email me on the weekend, it's gonna be longer than that, because I don't open CourseDen on the weekends usually, and it doesn't give me push notifications that I have emails. Tracy W@westshire.edu pings my phone 24/7. I am an insomniac. Sometimes I'll answer an email at 4 a.m.
Most professors actually.
Really?
Computer science people are up all night
Okay,
sometimes.
that's just the case. People be planning directions like.
No, don't apply that to other professors.
But when it
Now,
comes to the CS professor.
If you email me at 7 or 8 o'clock in the morning, that's when I'm
maybe some of
probably
the other
asleep.
scientists might-
All right, go, unless you need me for something.
Yeah, right. I got an email from a math professor at like 5 in the morning.